Screaming. Make sure that we're blowing up. Okay, we are live. All right, so today, before I get into this lesson today, I want to make sure you understand something. What we're going to be learning today is just a very, very basic introductory into something we're going to do all year long. It's going to be hard today. You're going to be like, it's okay. I just want you to try for me today. And as the year progresses and we do this more and more and more, we'll get better at it, okay? Right now, we're just sort of getting the basic concept down. And what we're talking about is about writing proofs. Now, what a proof is it's you take information you know and you use that information to prove something is true. You guys do this all the time. When you get into an argument with somebody and you want to win the argument, you back yourself up with information, right? You tell the other people facts to back up what you're saying so that you are the winner of the argument. You do it all the time. We're just going to write it on paper. And we're going to do it with geometry, okay? So the first type of proof that we're going to look at, let me back up just a second. Before we get into the actual proofs, there are some things that we need to know that we haven't talked about yet, and they are some specific properties that mean something in geometry. So the first one is called the reflexive property. Let me move that over to my. So the reflexive property says, I've got a note card over here because I don't want to mess these up. Says that if you have segment AB, it is congruent to segment AB. Now that sounds crazy, don't it? Here's when this would come into play. Let's say you have a triangle like this, right? And that triangle has a line that goes down through here that is segment AB. This segment is part of triangle 1 and it's part of triangle 2 over here. And if we're talking about this triangle, this segment AB is one segment. And if we're talking about this triangle, this segment AB is a separate segment. But it's the same segment, right? So we know that it's congruent to itself. It's the same size in both of the triangles. Does that make sense? So if we have to compare a segment to itself, we use what's called the reflexive property. Y'all with me so far? Okay. Then we're going to look at one. Do I need to hold on a minute? Everybody good? Okay, so then we're going to look at one called the symmetric property. Property. So the symmetric property says if AB is congruent to CD, then CD is congruent to AB. So you're just flipping it, right? They're congruent to each other, but that's the symmetric property. Okay? And then the last one that we're going to look at is called the transitive property. And the transitive property is going to look real familiar to you. I said last one, we actually have one more. So the transitive property says that if segment AB is congruent to segment CD and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. Does that look familiar to you? Looks a whole lot like the law of syllogism we did yesterday, don't it? The law of syllogism is a type of reasoning The transitive property is the property that we cite if we use that law of reasoning. Okay? So if you put law of syllogism, I'd be okay with that because it is the same thing. Okay? So transitive property is basically just the property that describes the law of syllogism. I love the word syllogism. I think it's such a cool word. Sometimes words just strike you, you know? That's one of them. All right, we've got one more thing we got to look at, and this is one that we already know. We're just going to refresh our memory on it. Something we've already talked about. So if you have a segment, and that segment looks like this, right? Then segment AB plus segment BC is going to be congruent to segment AC. Now we know that's true. If you take this little piece and you add this other little piece, you're going to get the whole thing, right? But this has a name. This is called segment addition postulate. Now that's the first time we've used that word, isn't it? All postulate means is geometry rule. That's all it means. It's just another word for saying, another way of saying a rule. It's something that's assumed to be true. If you Google the word postulate, it says something like things that are assumed to be true over time or something like that. Okay? So that's the segment addition postulate. Now we're gonna piggy bank on that just a little bit. So if we know that this segment and this segment added together is congruent to this segment, then what do we know about the measure of AB plus the measure of BC? What is it to the measure of AC? It's equal to. Now, what's the difference in those two? What are we talking about here? What is this describing up here? What are these? What are these? What is the difference in the two? Does anybody know? Well, you got to guess? Come on, throw out something, Anthony. What if you're right? You could be the hero. Yeah, so why do we use an equal sign here and we use a congruent symbol there? That's the question. Does anybody remember why? What's the difference between using a congruent symbol and an equal symbol? Okay, so this is a good thing we're refreshing our memory on this. Congruent symbols are for shapes. Equal symbols are for numbers. So if you're talking about the measurement of something, that's a number, like 7, 2, 12, right? But up here, this is not a number. This is the shape itself. So we say shapes are congruent, but their measurements are equal. Okay? Jonathan, does that sound good? So, I'll tell y'all that in a minute. All right. So those are our basic things that we're going to talk about. There's a few more that we'll add in as we go today, but that's the basic start, okay? So you should have your skills practice 2.7. I don't know if y'all noticed, but we skipped 2.5 and 2.6. So 2.5 and 2.6 to me weren't necessary. I could teach you what 2.5 and 2.6 teaches you doing 2.7. Okay? So that's it. I just skipped them because they weren't necessary. All right, so it says justify each statement with the property of equality, a property of congruence, or a postulate. We need to talk about properties of, now we'll do it when we get to it. Okay, it says QA equals QA. What is that? It's one of the ones we just talked about. It is the reflexive property. It is the reflexive property, but we're going to add to it just a little bit. So remember this said property of equality and property of congruence up here? Equality is any time that you have an equal sign in it. Congruence is any time you have a congruent symbol. So this is going to be the reflexive property of equality because it has an equal sign. Y'all see what I'm saying? If this had segments over it and it had a congruent symbol like that, then it would have been the reflexive property of congruence. Do y'all see the difference? Okay. All right, let's look at number 2. If segment AB is congruent to segment BC, and segment BC is congruent to segment CE, then segment AB is congruent to segment CE. What are they doing there? What's happening? They're using one of those properties we talked at the beginning of class. Y'all see if you can figure out which one. We only talked about 3, so it's got to be pretty easy to narrow down, right? Nobody else knows, so if you're right, you're a hero. If you're wrong, you're just like everybody else. What you think? You're not even going to guess? It is the transitive property. Yes, it's the transitive property. So now, is this going to be the transitive property of equality, or is this going to be the transitive property of congruence? Of congruence. Why? It's got a congruent symbol instead of an equal sign. So transitive property of congruence. Okay? Now the transitive property, basically it's like you're transferring ownership from one thing to another. So we start off saying that AB is equal to BC, right? And then they tell us that BC is equal to CE. Well, if they're both equal to the same thing, then they have to equal each other. We're transferring their equalship to each other through BC. BC is what connects them. Okay? All right, let's look at 3. If Q is between P and R, then PR equals PQ plus QR. Now, the very first thing you should notice is what symbol are we using? We're using an equal sign, right? That means what are we talking about? Shapes or numbers? We're talking about numbers. So this means the measurement of those, right? Now, I don't know about you guys, but I like to see a picture of what I'm looking at. So I'm going to sketch out what it says. It says if Q is between P and R. That means I've got a segment called PR, and Q is somewhere between them. Doesn't matter where, just somewhere between them. And then it says PR, which that means the measure of PR, because it doesn't have a symbol on top, is equal to PQ plus QR. Right? So, back to our properties of equality that we talked about. I mean, our different properties we talked about earlier. Where'd I put that piece of paper? I'm using it. Our different properties that we talked about. Woo, wrong way. Which one of those properties is going to deal with those segments being added together? The segment addition postulate. So what's our reason on this one right here? We're just going to put the segment addition postulate. Because we're just saying if we add segments together, they add up to the one big segment. Okay, number 4. If AB plus BC equals EF plus FG, and AB plus BC equals AC, then EF plus FG equals AC. Y'all see what they did there? I'm going to write it out so we make sure that it makes clear sense to us, okay? We've got AB plus BC equals EF plus FG. Then we have AB plus BC equals AC, right? Notice this is the same thing on both sides. Oh, notice that? That tells us that this thing and this thing have to equal each other, which is what they said. Now, number one, are we dealing with shapes or numbers? Numbers, how do we know? Equals, because it has equal signs instead of congruent. So these are the measurements of those things, right? We're dealing with numbers. What property of our properties was that? Is that going to be reflexive property? Did we say AB equals AB? Is it the symmetric property? Did we just flip it? We did not, did we? Is it going to be the transitive property? Yes. So this is going to be the transitive property, but is it the transitive property of congruence or equality? Equality, because we have equal signs. So it's the transitive property of equality. Now, I will tell you this also. There's a reason, because we're going to talk about reasons in just a minute. There's a reason you could get by with using for this instead of transitive property of equality. And that reason is substitution. So you could use the reason substitution instead of transitive property of equality, because we're substituting one thing in for another thing. And so you can just call it substitution. Does that make sense? Okay. Okay, so now we're going to go down here to the bottom. We're going to look at number 5. Now, the directions say complete each proof. Y'all see those directions right there? Complete each proof. And if you look at this, this looks so overwhelming, right? But let's back it up and talk about what a proof is. So all a proof is us making an argument to prove something's true by telling you all the things we know that make that true. That's all a proof is. It's just an organized way to put your thoughts of how you know something down in order and tell me why you know that. So there's different kinds of proofs. We're going to focus on doing a 2-column proof because I think they're the easiest. And then once we get a 2-column proof down, we'll start using that 2-column proof to build other proofs like paragraph proofs or flowchart proofs. But 2-column proofs I think are the easiest kind of proofs to do. Now, I do not like fill-in-the-blank proofs. I don't like taking someone else's thought process and trying to figure out what they were thinking, because my thought process and someone else's thought process are not always the same thing. But to introduce this to you, I'm going to do a fill-in-the-blank proof, okay, so that you get the idea of how it works. Then we will do our own proofs after that, all right? But to start off with, we're going to do some fill-in-the-blank proofs. So here's the information that they gave you. They said segment SU is congruent to segment LR. So if we look at the little diagram over here, that means that this whole segment here is congruent to this whole segment here. And then they said TU is congruent to LN. So I need to mark that on mine. So TU is congruent to LN. I'm going to put a little mark on that and that just so that I remember that's what that says. Now that information was given to you. They told you this. You know it's true because they told it to you. All right? Then the next thing they say is prove that ST is congruent to NR. So what we're looking for is this ST congruent to that NR? That's what we're trying to prove. Now, you probably already know that's true, don't you? You already know that. What we're going to do on paper is just show how we know that. That's all a proof is we're walking through the mental steps that your brain goes through to go from this to this. Now, your brain does it like that. But we're going to break it down step by step. Okay, if we know this, then we know this. If we know this, then we know this. All right? So let's start with the very first statement. And the very first statement says, segment SU is congruent to segment LR. Segment TU is congruent to segment LN. Oh, I didn't tell you all this. So a 2-paragraph proof a 2-column proof is 2 columns. And the column on the left is your statements. This is what you're stating. You're saying this is true. The column on your right is your reasons. And that's where you give me a property or a theorem or a postulate or something that shows me why you know that's true. Okay? So, segment SU is congruent to segment LR. Segment TU is congruent to segment LN. How do we know this? What's our reason for knowing this? Where did this information come from? What'd you say? It's a given. They gave it to us, right? So the reason that we know this is given. If they give you information, your reason is just given. Okay? All right, let's look at the next step. So notice in the next step, they put definition of congruent segments as the reason, and they left blank the thing we know. Okay. At the end of class. Okay. So, I'm going to just tell you this one, all right? Because I could ask you forever and you'd never guess this, all right? So, up here, we said that they were congruent to each other. So, if they're congruent, what do we know about their measurements? They're equal. So we go from they are congruent to saying that SU equals LR and TU equals LN. Now, I know that seems like we're splitting hairs talking about the difference between congruence and equals, but it is a difference, okay? So we do have to go through that process of, well, the shapes are congruent, the measurements are equal, okay? Now let's look at C. So on C, notice that they're not using congruency anymore. So what are they talking about? They're talking about numbers. They're using equal signs, so they're talking about measurement, right? So they say SU is equal to ST plus TU. So SU, that's the whole segment, right, is equal to TU plus ST. And then they said LR is equal to LN plus NR. So LR, that's the whole segment, is equal to LN plus NR. Okay? How do we know that's true? It's one of the things we talked about today. It's a segment addition postulate. The segment addition postulate is something that is just known to us. We just know it. Like we almost know it from birth, right? Like you just know that if you have two little segments and you add them together, they make up the bigger segment. But when we write down our reason, we're going to write down segment addition. And I don't even care if you use the word postulate or not, as long as you've got the segment addition part down. Okay? Now, theoretically, using postulate is part of the answer. But for me, as far as I'm concerned, I just want you to know that you're talking about segment addition and that that's a thing. Okay? Okay, so then we go to D. And in D, so every step of this proof is someone's brain process, right? So we're going from C to D. What changes from C to D? So up here, they tell us that these two add together to give the bigger one. Now down here, they're saying ST plus TU equals LN plus NR. How do we know that's true? Now remember, the very first statement that was given to us was that those two segments were congruent, right? So we know if the two segments are congruent, then we also know that the measurements are equal to each other. We know that, right? So if we know, I'm going to write this down so maybe it helps you. So we know that SU equals ST plus TU, right? And we also know that SU equals, I'm going to go this way. You don't normally write like this, but equals LR. We know that, right? And what do we know that LR equals? LN plus NR, right? So if these two equal each other, and they equal these things respectively, what do we know about these two things? They equal each other, right? And that's what they made this statement here, right here. Everything okay? Yes. Okay. So they made this statement right here that LST plus TU equals LN plus NR, because they're just taking this and they're substituting it in the place of that LR right there. Y'all see? So our reason right here is just substitution. I'm telling you right now, you can use substitution on a proof so many times, can't you? You remember doing these?
Yeah. I think I like it.
Mm-hmm. It was hard at first, right?
Yeah.
But then once you got the hang of it, it wasn't that hard. Yeah. You had for me for geometry, didn't you?
How do you like it?
Algebra 1 and geometry.
Yeah.
Did you have me for something else too?
I think so. Unfortunately, I didn't.
You're a senior this year? Were you my aide one year?
Was I what?
Aide?
I think I had to like really early too. I don't remember what day.
I don't either. I know you've been in my classroom a lot.
Yeah.
Okay, so the next step. ST plus LN equals LN plus NR. Where did that LN come from right here? Where did this come from, y'all? Anybody have any ideas where that came from? It came from the given, didn't it? Remember up here in the given, they told us that TU equals LN? So they're replacing this TU with LN. They're just replacing it. So what did they use? What's their reason for knowing this? Substitution. All they're doing is substituting in LN for TU. That's all they're doing. All right, let's look at the next step. So what changed from E to F? What are they doing to E to get F? What happened? They're subtracting LN from both sides. What would be the purpose for subtracting LN from both sides? To take it away. Their goal is to get rid of it, right? Now, our textbook, they call this something different than what I would call it. So, you don't remember when you learned how to do algebra, you learned about how all of these, you had all these properties of equality, and it's every operation has its own property of equality, and it's what you're doing to both sides, right? So if you add something to both sides, it's called the addition property of equality. If you multiply both sides by something, it's called the multiplication property of equality. Well, this what are you doing to both sides? So it's called the subtraction property of equality. Because you're doing it to both sides. Anytime you do something to both sides, you call it the property of equality. You gone?
Yeah.
So you didn't need me?
Yeah.
Okay. Bye. See you later. All right, so let's look at G. So what happens? So they've got substitution down here. What happens to this? What happens after we subtract ln from both sides? What do we get? That's what's going to be our next step. What do we have? So we have ST equals NR. Thank you, Jonathan. ST equals NR. Because we're subtracting the ln, it gets rid of the ln, right? So this ln gets rid of that ln. And this ln gets rid of that ln. So it's gone. And that's just substitution because all we're doing is like substituting what we know. Okay? Now, this is an equal sign. So ST and NR are what? They are equal, but what are we dealing with? Anthony, I need you to chime in here. Equal sign, what does that mean? It means equality, which means what are ST and NR? Equal, which means they are what kind of thing? They are the same, true. Now, y'all, I am not pressing the right button. Are they shapes or numbers? They are numbers. So we're saying the measure of ST is equal to the measure of NR. Right? Now, remember what we were trying to prove. That ST is congruent to NR. Right? So, but if we know their measures are the same, what do we know about the shapes themselves? They are the same. If we know the measures are congruent, are equal, we know the shapes are congruent. So our next step here is to say, oh, so if they're equal, the shapes are congruent. So what is our reason for knowing this? Anybody have an idea what our reason for this would be? Which one? Well, it's not given.
It's not given, but it is given.
So this one is one we didn't talk about. This would be called the definition. So you can use definitions as your reasons too. And normally I would abbreviate that and put DEF, but since this is a video, I went ahead and put it out as definition. Definition of congruent segments. Now remember, we used this once before. Up here. Definition of congruent segments. That's when we went from being congruent to being equal. Now we're going from being equal to being congruent. Y'all see how that works? Y'all just wrote your first proof. Go you! Was it that bad? The first one's hard. And it's really hard to fill in somebody else's blanks because our brains and someone else's brains do not process information the same way. I'd much rather write my own proof than fill in somebody's blanks. But I wanted you to see what it looked like the first time in a step-by-step one. Okay? Everybody with me? So, I need you to hang on to 2.7 and 2.8. And tomorrow, we're going to look at 2.8. So, tomorrow's Thursday. Tomorrow, we're going to look at 2.8. I'm going to give you Friday as a work day. You'll be able to work on 2.7, 2.8, anything else that you've got missing. We are looking at a test on Tuesday. We'll do a study guide on Monday and a test on Tuesday.
Do we read our Chromebooks series?
Are you going to? Yeah, probably. But not at first. So just wait.
Okay.
Because you won't need it at first.